Welcome to G Fun Facts Online. Imagine slipping on a t-shirt that tracks your heart rhythm, a jacket that charges your phone as you walk, or a firefighter's uniform that sniffs out hazardous gases. This isn't science fiction. This is the world of woven computers, a technology that's turning the very fabric of our lives into intelligent, active companions. These aren't just clothes with gadgets clipped on. The electronics are woven directly into the threads, creating a system that's flexible, comfortable, and increasingly even washable. We're standing at a fascinating intersection of material science, electronics, and fashion, and today we're going to unravel the threads of this incredible technology. The idea of weaving and computation are actually old friends. Their story begins in the early 1800s with Joseph Marie Jacquard and his revolutionary loom. This wasn't just any loom. It used a series of punched cards to control the weaving of incredibly complex patterns. Each hole on a card was an instruction, a binary system of on and off that told the loom exactly what to do. This was, in essence, the world's first binary code, a direct ancestor to modern computer programming. Fast forward to the 20th century, we saw calculator watches and other bulky gadgets, the clumsy first steps of wearable tech. But the real breakthrough came in the 1990s at MIT. Researchers like Steve Mann and Thad Starner started strapping computers to their bodies, creating the first wearable computers. But another MIT group, including Maggie Orth and Remy Post, had a more elegant idea. What if the electronics were part of the soft material itself? They developed methods for embroidering circuits, creating truly soft electronics. This work was pushed even further in 2007 by Leah Buchley, who created the LilyPad Arduino, a small computer designed specifically to be sewn into fabric, opening the door for artists, designers, and hobbyists to start experimenting. So how do you actually build a computer that you can wear? Let's look at the anatomy of these smart textiles. At the very heart of a woven computer are conductive fibers. Think of these as the nerves of the system. They are threads that can carry electrical signals, just like the wires in your phone charger. There are a few different kinds. Some are made from metals like silver or stainless steel, which are fantastic conductors but can be a bit stiff. To solve this, scientists are using incredible new materials, like carbon nanotubes and graphene. These are not only highly conductive, but also extremely lightweight, strong, and flexible. Another approach involves conductive polymers, which are plastics engineered to conduct electricity. They are very flexible and can be blended right into traditional textile fibers, like cotton or polyester. The choice of fiber all depends on the job it needs to do, balancing conductivity with comfort and durability. Once you have these conductive threads, you need to build circuits with them. This is where old-school textile manufacturing gets a high-tech upgrade. Using industrial weaving machines, you can interlace conductive and non-conductive yarns to create what is essentially a flexible fabric circuit board. Digital knitting machines can also be programmed to loop conductive yarns into specific patterns, creating circuits that are stretchy and perfect for close-fitting garments. You can even embroider circuits onto existing fabric using conductive thread, which allows for incredible precision. Or, you can use special conductive inks to print circuits directly onto a textile, creating ultra-thin and lightweight electronics. But a circuit is useless without a brain. Woven computers need microcontrollers, sensors, and other components. The challenge has always been making these parts flexible enough to be part of a soft garment. Recent breakthroughs in flexible electronics have given us components that can be bent, stretched, and even washed. These tiny electronic brains can be integrated right at the fiber level. In fact, some researchers have managed to create an entire computer system with sensing, communication, and storage, all within a single, thread-like fiber. That's a complete computer you could literally sew into a shirt. Of course, for a smart garment to be useful, it needs to be able to sense the world around it and react. This is where sensors and actuators come in. Sensors are the senses of the fabric. They gather information. You can have physiological sensors that monitor your health, like ECG sensors woven into a shirt to measure your heart's electrical activity, temperature sensors to track your body heat, or respiration sensors to monitor your breathing. Motion sensors like accelerometers can track your physical activity and even analyze your posture. Then there are environmental sensors that detect things around you, like the air temperature, humidity, or even the presence of specific gases and chemicals in the atmosphere. Once the sensors gather this information, the actuators allow the fabric to respond. Actuators are the muscles of the system. For example, tiny vibrating motors can be embedded to provide haptic feedback. Imagine a jacket where the sleeves vibrate to tell you whether to turn left or right while navigating. This technology is also being used to create more immersive virtual reality experiences. We're also seeing shape-changing materials. Shape memory alloys and polymers are materials that change their form when an electrical current or heat is applied. A garment could use this to tighten and provide compression to an athlete's muscles on demand or to adjust its fit automatically. Other actuators include heating and cooling elements for thermal regulation, or tiny LEDs woven into the fabric to create dynamic displays or visual alerts. A garment that changes color with your mood or displays a message is no longer just a concept. But with all this technology, two huge questions remain. How do you power it? And how does it communicate? Power is one of the biggest hurdles. You can't just plug your t-shirt into the wall. Researchers are developing thin, flexible batteries that can be woven directly into the fabric and can be twisted and stretched without failing. But the truly exciting frontier is energy harvesting. The idea is to create self-powered garments that never need charging. This is being done in a few ways. Photovoltaic fibers, which are essentially tiny solar panels in thread form, can be woven in to capture energy from sunlight. Other materials, known as piezoelectric and triboelectric materials, can generate electricity from your body's movement. Every step you take, every time you stretch, you could be powering your clothes. And thermoelectric materials can generate power from the temperature difference between your warm body and the cooler air around you. For communication, the data collected by the sensors needs to go somewhere, usually to your smartphone, for analysis. This can be done through the conductive threads themselves for communication between components within the garment. For external communication, textile antennas can be woven or embroidered into the fabric. These can transmit data using standard wireless technologies like Bluetooth or Wi-Fi, seamlessly connecting your clothes to your other devices. The potential applications for this technology are staggering and set to redefine entire industries. In healthcare, woven computers can act as a second skin. Imagine smart garments for patients with chronic conditions, the elderly or newborn infants, continuously and unobtrusively monitoring vital signs like heart rate and respiration. If a problem is detected, an alert can be sent to a doctor or family member in real time. These textiles can also be used for treatment. A smart sleeve could be programmed to deliver gentle electrical stimulation to help a patient recover from a muscle injury, or even release medication through the skin at precise intervals. In sports and fitness, smart clothing is already helping athletes optimize performance. Garments can track movement, posture, muscle activity, and hydration levels, giving coaches and trainers real-time data to prevent overtraining and reduce the risk of injury. For the military and safety workers, this technology is a game changer. A soldier's uniform could have integrated sensors that detect toxic gases or monitor vital signs on the battlefield, relaying their status and location back to a command center. A firefighter's jacket could sense when external heat levels become dangerous, triggering an alarm. In fashion and entertainment, woven computers are unlocking new forms of self-expression. Clothes that change color based on your mood, dresses with animated light displays, and gaming suits with integrated haptic feedback are all becoming a reality. Even the automotive industry is getting in on the action. Smart textiles could be integrated into car seats to monitor a driver's posture and fatigue, perhaps even providing a gentle massage on a long drive to keep them alert. But despite this incredible potential, there are still major challenges to overcome before woven computers become a part of our everyday lives. The biggest one is durability and washability. Can these complex electronics survive a spin in the washing machine week after week? Scaling up production from lab prototypes to commercial manufacturing at a reasonable cost is another significant hurdle. And as we've discussed, providing a reliable, long-lasting power source remains a key focus of research. Perhaps most importantly, we have to consider the ethical implications. These garments will collect immense amounts of personal data about our health, our location, and our activities. This raises serious questions about privacy and data security. We need to establish clear rules and robust security measures to ensure this deeply personal information is protected. Despite these challenges, the future of woven computers is incredibly bright. Researchers are constantly innovating, developing new materials and manufacturing techniques that are making these textiles more durable, affordable, and powerful. We are witnessing a fundamental shift in how we interact with technology. Our devices will no longer be just objects we carry. They will be woven into the very fabric of our world. The dawn of this new digital age is here, and it promises a future that is smarter, safer, and more connected than ever before. Thanks for tuning in to G Fun Facts Online.